Example 5. Directions. The letter X and Y represent rectangular coordinates. Thus, it does. Okay. Write each equation using polar coordinates, which is represented using letters R and theta. So before we start, I will again remind you, okay, x squared plus y squared, it's always r squared. Then x is always what in polar? X is always r times cosine of theta. Then y is always what in polar? R times sine of theta. Okay, so these are the things that you're going to have to know and write it down every time. So the more you write, the more it's going to help you. Okay, and you're going to memorize that much faster. So A, currently it's all in x and y. My goal is to get it all in polar. That means I shouldn't see any more x's and y, right? Everything should be in radius, r, and theta. So the first thing I see is they both have 4 in common. So I will factor out a 4. So I have x squared plus y squared equals x. Whoa, what do we see here, right? X squared plus y squared is r squared, yay, and bring down the 4, okay? So look, I don't have any more x's and y on the left side. I still have 1x on the right side. So the right side, x is this, right? But x is always what? Equivalent to r cosine of theta. Yes, you can simply just replace it like that, okay? Now, I will totally accept this answer the way it is, okay? If you choose to move it to one side, which I believe your book does, okay, so that way it equals to 0, you can also do that. But I will always accept the simplest answer. Whether you move it equal to 0 or not, it's still going to be in the simplest form. You can't really do anything else, okay? Okay, here we go. Example 5b. How do you write x equals -4? Okay, so this is a vertical line as a function in polar. So, well, it's simple, right? X is just simply what? R times cosine of theta. That's it. X is always can be substituted with R times cosine theta. And -4 is dropping down as -4. Voila! That is so hard, right? I'm done. Now your book likes to sometimes write it in terms of R. What does that mean? That means I'm dividing both sides by cosine. The reason they do that is because you can plug it in your calculator and easily check your answer, which is fine, okay? You can have either one. I would take r cosine of theta equals to -4, or r equals -4 divided by cosine of theta. Either one will both be, when you graph it out, you're still going to get a vertical line. And yes, you will eventually will learn how to graph these. Hi class, this video is for 9.1, example 6. Example 6, the letters r and theta represent polar coordinates. Write each equation, I suppose without plural, using rectangular coordinate, which is x comma y, okay? So before we start, we will write down some key things that are important for us. So the first thing that I'm going to remind you, it's r squared. It's always x squared plus y squared, okay? Another one that's important is going to be x, okay, equals r times cosine of theta. And another one that's going to be important is going to be y equals r times sine of theta. These three things are so important for converting polar to rectangular and vice versa. All right, so here we go. A, r equals to cosine of theta plus 1. Right now, I know what r cosine of theta is, okay? But in your problem, it just gave me cosine of theta. So what I'm going to do is I'm going to rewrite my equation, okay? And from here, I would like to multiply both sides. Yes, you can do that, okay? What you do one side, you want to do to the other. And the reason I want to multiply both sides by r is that way I can get to this. Would you agree? I don't want to square both sides, which is also okay to do at times, okay? But squaring both sides here is not going to help me on the right side. So that's why we are going to multiply both sides by r instead of squaring both sides. Again, you can square both sides and you can multiply both sides by r, but squaring both sides on this one will not help us. Okay, so r times r is r squared. Co times r distribute, that's r cosine of theta. 1 times r is r. Can you see that this is right now x? Okay, now r squared, it's also x squared plus y squared. Remember, we're trying to convert it into rectangular. That means only x's and y's are left behind, okay? Now, this one says r is what I need to convert it out. Well, earlier, if r squared is x squared plus y squared, then r can be thought of as square root of x squared plus y squared. So yes, you can also drop it down just like that. Okay, so this is as simplified as it's gonna get. Okay, now if your book, okay, moves it so it equals to 0, that's also okay. So what if your book moves this to this side and then this to this side as well? Okay, so that means it's x squared. They want to put all the x's together, no big deal. Bring down the y squared. Move the radical on the left-hand side. So now you have a negative radical squared equals 0. That's also okay too, if that's what the book has, okay? So if the book likes to write it equals to 0, it's okay. If you want to keep it as is, as long as it's in the simplest form, that's also okay too. So it's really up to you, okay? All right, next. R equals 3, okay? Now r is radius, right? So this is really saying radius is 3 units, right? With no angle given. Not funny, sometimes in polar coordinates they don't need to give you an angle, and sometimes they give you an angle without the radius. So I want you to think for a second, okay? What shape has a radius of 3 units all around, okay? Well, as you're thinking that out, I'm going to work this out manually. So they gave you r equals 3, okay? Now, this is the one that I will square both sides, okay? Because when I square both sides, now I have r squared equals 9. Unlike A, this one squaring both sides is still going to give me a nice solution, okay? Well, r squared can be now substituted with x squared plus y squared. That still equals to 9. I am done. This is all in rectangular form, okay? Well, think about it. We studied this already, okay? This is a circle, you're right, with the radius of 3, okay? So this in rectangular will always be the same shape as polar, okay? So polar is usually more like graphing around, using angle and radius, but in rectangular we use x and y. Doesn't matter, sometimes we can still get the same shape. This is the end of example 6. So we are picking up from 9.2, polar equations and graphs. So on here, on the left side here, this is what we have always seen up until today, right? This is what we call a Cartesian, or in this chapter, they call it a rectangular plane, okay? So if I use the word Cartesian plane or rectangular plane, it's really talking about the x and the y coordinate that we have always used up until now. Now over here, when you have radius and when you have angles, this is what we call the polar plane or polar grid. So here we go. An equation whose variables are polar coordinates, it's called a polar equation. The graph of a polar equation consists of all points whose polar coordinates satisfy the equation. Now we will be graphing polar equations on the calculator or Desmos. So it says here, let's explore using graph r times sine of theta equals 2, and then what do you see? Now before you take out your calculator, make sure you guys change it to polar format here and make sure you're in radians. So go ahead and take out your calculator, change that out. Now before we can even start graphing, just like graphing in Cartesian plane, we have to have y equals. Now in polar, we have to have r equals. So what we want to do is divide both sides here. So what you guys do to one side, we do it to the other. So I'm going to erase that equal. So now we can plug this in. So now it's really 2 divided by sine of theta. Now, as you know already, I don't have a graphing calculator software on this Surface Pro, but I do have Desmos. On Desmos, we will change a few things as well. So I'm going to find my Desmo. As this is loading. Okay, so go to the wrench here on the top right. What I need you to do is make sure on the grid, hit the one that looks like the polar grid. Then on the x's and y axis, I just need it to be a square. So when I mean a square frame, meaning that it goes from -10 to 10, or if you want to go -5 to 5, whatever the value you have chosen, just make sure it's a square. No, it doesn't have to be a square. It just looks a little bit better when it is. Okay, just like that. Now we want to punch in. Also, double check to make sure we're in radians and not degrees. Okay. So what we want to do is we're going to type in r equals. Then we said 2 divided by sine. And then if you type in the word theta, the symbol theta will pop up in Desmos. So that's what it looks like in Desmos. As you can see here, it's a horizontal line right at 2. Again, it's a horizontal line at y equals to 2. Then we want to go back to our notes and write that in. Where it says, what do you see? This is what I want you to spell out and be very specific, okay, of what you saw. So you can say it's a horizontal line at y equals 2. Now on your calculator, you want to go to y equals, but it doesn't look like that anymore. So mind you, on your calculator, once you hit polar, you change the mode to radians and polar, you don't see y equals anymore. You see r equals, and that's okay. You can do the same thing. So you can go y, and this is, I'm sorry, not y, duh, I just said that, didn't I? R1 equals 2 divided by sine of theta. Now on your, and theta is the same location as x, okay? So 2 divided by sine, go ahead and punch it in, and you're still gonna see theta. Now, in addition, on your calculator, go to window. So go to window for me. The theta minimum, theta min, I want you to do it from 0, and then theta max. This is a full revolution, so we want to do 2 pi. Then in addition, you also have this step, okay? So theta step. Don't do anything with this step, just leave it at the default value. This is how fast you want it to graph. So again, right now, about 0.13 is just fine. Leave it as its default. Now the x min and x max, again, I want you to go from -10 to 10 on your calculator. And then y min, y max, same thing, okay? You can change this later as needed, but usually just leave it as a default from a square window. On your graphing calculator, it's a little strange. The reason it's a little strange is because your calculator has a rectangular window. So it looks more rectangular than what we're normally seeing. But if you just graph it out, and you should have a horizontal line, okay? So that's how we use technology to graph out our polar. In years past, we always graph all of these by hand.
But this year we will graph some of them by hand, the easy ones, and then the more difficult one, or I wouldn't say difficult, the more time consuming one, we will be graphing those using technology. So now number 2, I want you to do that on your own. Again, be very descriptive of what you see. Again, you have to solve for R. So right now that's not possible for you to graph. So make sure you solve for R and fill this in. If you need to, hit pause and do that for me. And we are now moving on to the theorem because you guys have already done number 2 on your own. Theorem, let A be a non-zero real number, then the graph of the equation r sine of theta equals A, which is the first one that we try, that was the horizontal line at y equals to 2, is a horizontal line at y equals A. Okay, there's a horizontal line at y equals A, or it says here. How about this? We'll do, because I forgot that I already filled out that. It's just a horizontal line, and horizontal and line's already there. So look at that. I'm making it easier for you. It's a horizontal line, A units above the pole. Okay, remember the pole is right in the middle. If A is positive and the absolute value of A units below the pole is, and so if A is positive and absolute A value units below the pole if A is negative. The graph of the equation r cosine of theta equals A is a, and then that was number 2. You have to fill that out. So this is going to be a vertical line. A unit to the right of the pole if A is positive, and absolute A unit to the left of the pole if A is negative. Number 3, using a square screen, I want you to graph this out, all 3 of them, okay? And what shape is it? And then you write that, fill those out right there for me. Tell me the shape, tell me the description, okay? If you have a shape, fill that in, and then answer this part as well. So because we have 3 equations, you can write them using a comma here on the radius part of it. Okay, so now you're done with that one. If you need to, hit pause. Go ahead and do number 4. Okay, so 3 and 4, you are on your own. What I will do with you is we'll do number 5 together. So I'm going to find my Desmo. I will clear out this one. This first one says r equals negative cosine of theta. So r equals negative cosine theta. That's my first one. Then the next one, it says r equals negative 3 cosine of theta. Then the last one, oh, how many are there? 1, 2, 3, 4. 1, 2, 3. So I got negative, negative, positive, and positive. Okay, so I got positive r equals 3 cosine of theta, and then theta, and last one r equals 6 cosine of theta. And then I need you to fill out the shapes. Looks like they're all circles, okay? Looks like they're all circles. And then the radius, the blue one has a radius, not a diameter, okay? So let's see. The radius is going to be half of a unit. The diameter looks like a full unit, but the radius is only half, okay? And then the green one, the diameter is 3, okay? And then the purple one, the diameter is 3, but it's on the right side because your value 3 is positive. And the black one has a diameter of 6 units, and it's on the right side. So we want to be descriptive with that. So this is all circles, okay? They are all circles, and the origin for each one is different. Would you agree? Whoops. Uh-oh. I want to go to pick up honors. There you go. Okay. So the circle, the first one, the origin, we're going to write that here. It was a negative half comma 0. But let's verify that really quickly. So the first one was the blue one. Okay, so the radius was half a unit, and then it was on the left, so negative half, comma 0. Then the second one, it was the diameter is 3. So the radius is going to be a half. So the center, the origin of that is going to be negative 1.5, comma 0. So negative 1.5, comma 0. Then this last one, we know, not last one, we have two more. So r sub 3, it was positive 1.5, comma 0. Then the last one, R4, it is 3, comma 0. So those are the origins of each shape. Now the radius is going to be half of the leading coefficient in the front. Okay, so half of the number in the front. So, and the number in the front is called the leading coefficient. So you can spell that out as well. So if you want to spell that out, you can do that. Now that you have explored the pattern, please formulate a theorem that we can use. Okay, all right, let's do it. So we have a few equations here. So r equals 2 times a times sine of theta. Now this is a circle. Whoops, if I can spell a circle. This is a circle. And because this number is in the front and it's 2a, and we said, okay, well, the radius is half of that, so the radius is just 1a. And then it says here, tell me the center. The center, because that's a positive 2a, the center, as you can see, we formulated up here, right? The center is going to be just that half of the number in the front, so it's going to be a, comma 0. Then we have r equals negative 2a sine of theta. It's, again, a circle. And the radius is always positive, it's just a distance. But when we wrote that out, we wrote it as, sine is a little bit, my bad, sine is 0, comma a. So this is going to be 0, comma negative a, because sine is going to be above the pole or below the pole. Then cosine was the example of number 5 that we did. So this is, again, they're all circles. So we're going to write circles straight down. And the radius is always going to be half of the number in the front, so it's just going to be 1a. Then because 2a is positive, the center would be a, comma 0, and then this would be a negative a, comma 0. Each circle, oh, that's my alarm. Each circle passes through the pole. Okay, so that means passes through mean it touches. So each circle passes through the pole. So if somehow you're graphing it by hand and it's not going through the pole, then that means you did something wrong. Hey guys, this is the recording for example 9-2. Okay, example 1 from 9-2. So transform each polar equation into an equation in rectangular coordinates. Okay, then identify and graph the equation. Then verify your graph using your graphing utility. Now this last piece, okay, I'm not going to do here on my recording, but you can definitely do that when you're working on your homework. Okay, so that way you know whether you're graphing it right or wrong. But if you know for sure that you don't that you're on the right track, where you check the back of the book and you're doing it right, then it's great. But if it's an even answer and you don't have the answer in the back of the book, then it's a good idea to use your graphing calculator and check it out to see if graphing by hand is correct. Okay, so the first part says, hey, transform each polar equation into an equation in rectangular coordinates. So all you're given is r equals 3. Well, you don't know what the angle is supposed to be, okay? All you know is the radius is 3 units all the way around, okay? That's all you know. So, well, to get to your rectangular, I need to know what x is, right? And to know what x is, I need to know y. But I don't have any of that information. So what do you think you want to do? First thing is, can I square both sides? Okay. So if I square both sides, I now have r squared equals 9. Okay. In rectangular equation, I can't have r. Okay.
I can have x and I can have y. So remember, you have to know r squared is always x squared plus y squared. Okay, so I can totally take out r squared and now put in x squared plus y squared equals 9. Voila! Okay, so this is the same equation in rectangular coordinates. X squared plus 9, y squared was 9. Well, this is actually a circle because it's identified. Okay, so it's a circle, and we are going to graph it out. This circle has the center at 0, 0. Okay, you can graph it out using rectangular coordinates, or you can graph it out using polar. Polar just says, hey, you know what? It's 3 units radius. So what does that mean? 1, 2, 3, right? Dots, 3, 3, 3. So in theory, polar means I have a radius of 3 units all the way around. What does that really mean? Because you don't know what the angle is, you just keep on going again and again and again, right? So it's a circle of radius 3. Now in rectangular form, you can still make this into a rectangular form, okay? Rectangular form just meaning that, hey, x-axis is this way, okay? Y-axis is this way. Center, according to this equation, center is 0, 0. Go up 3, down 3, left 3, right 3, and you're still going to get the same thing. Center at 0, 0, and radius is 3. So either way, you will still get the same exact answer, okay? Oh, look how annoying this is. Can you see like the bottom of that page is, I did not print or, I guess, format this right. So look, I have B is theta equals pi over 6, okay? Well, this is a little bit different, okay? A, all you know is the radius. B, all you know is the angle. Oh man, what does that even mean, right? If all you know is the angle and you do not know the radius, I mean the radius can be whatever it wants to be, just so you know, okay? All right, so, well, I first have to kind of write a rectangular form. The only thing that has theta in it that I can think of that has y and x is tangent. So tangent of theta equals y divided by x, okay? All I know is theta, okay? This theta is the same as this theta, okay? And I can substitute theta with pi over 6. So tangent of pi over 6 equals y over x, okay? Tangent of pi over 6 is radical 3 over 3 equals y over x. I'm going to solve for y. You are in rectangular, so let's try to solve for y. So cross multiply. So now we have, what, x times radical 3 equals 3y. Divide both sides by 3. Whoa, this is amazing. Y equals rad 3 over 3x, okay? You have to identify what this is. What is this? This is a line. It's a line. Isn't that amazing? Okay. This is totally a line. Okay. So let's graph it out. Okay. I'm going to demonstrate how I would be graphing this in rectangular format. Okay. So this line, here's my y-axis. Here is my x-axis in rectangular format, okay? This line has an intercept at 0, a y-intercept at 0, 0, okay? Then it has a slope of radical 3 over 3. Radical 3 is in between 1 and 2. So you can go, here's 1, here's 2, right? So go up radical 3 and then over 3 units. Well, I kind of don't have 3 units here because it's all in like polar form. So I'm gonna kind of eyeball what 3 units is, okay? Okay, so this is sort of, every one of this is 1 unit, okay? Kind of eyeballing it. So I'm gonna go up radical 3, run all the way to 3, okay? Up radical, so remember radical 3 is in, and then do that a couple of times, but looks like I could just do that one more time because I don't have enough marks here. So remember, again, rad 3 is in between 1 and 2, okay? So go up somewhere here and then run over 3 units, okay? So something like that. So look,
I now have 2 or 3 dots, in this case really 3 dots, okay? And I'm going to connect my dots, make a straight line. If you have to, use a ruler. All right, and I can even, since I have multiple colors, I'm gonna go rainbow on you. Whee! Okay. Okay, look at that beautiful line, right? These are the dots I use. Great, that's a line, okay? In rectangular format, y equals square root of 3 or square root over 3 of x. Now, how would I graph it out using polar? Well, polar, all it says is that all you know is the angle, okay? What happens to be pi over 6? And you don't know the radius. That means the radius goes on forever. So guess what? You are on the same exact line. Isn't that gorgeous? Okay. That's how we graph those out. So anytime you see a radius all by itself, it means it's going to be a circle, okay? Because you don't know the angle. That means the angle can be going around and around and around. Anytime you see a theta equals, that means it's a line, okay? Next, what do you think this is? R times sine equals -4. R times sine of theta equals -4. So let's try to figure out how to change this into rectangular format. Well, what is this? R sine of theta. What is that? R sine of theta. What is that? Is that y? Yes, it is. It's totally y. So here's your rectangular format. This is a horizontal line. Okay, it's a horizontal line. So, how do I graph horizontal line in rectangular format? Okay, so this one I would not show you how to do it in polar because you would need to do test of symmetry, and I'm going to test the symmetry below here. So right now we are just going to use rectangular format to graph. Okay. So I need 4 units below. So 1, 2, 3, 4. It's y equals -4. So I'm going to go horizontal line goes that way and a horizontal line goes that way. Isn't that gorgeous? All right. So y equals -4. Okay. Which is equivalent to r sine theta equals -4. So if you plug in, the calculator only takes r equals. If you plug in your calculator, you can test this out. -4 divided by sine of theta, it will give you the same thing. Okay. All right, next. D for dog. Okay. So this is D is the last one for this video. All right, D, r times secant of theta equals -8. You don't know anything about r secant of theta because all you know is x, right? X is r cosine of theta. Y is r sine of theta, but r secant of theta is not known. But that doesn't mean we can't convert it. So secant of theta is going to be 1 over cosine of theta equals -8. Okay, I'm going to keep on going. So from here, I'm going to have r over cosine of theta equals -8. I'm going to try to get rid of fractions. So multiply both sides by cosine of theta. So when I multiply both sides by cosine of theta, I have r equals -8 times cosine of theta. Okay. Now this looks like something that I can work with, except this, this color. R cosine of theta is x, right? What I'm missing is over here I have 8 cosine of theta. I'm missing r. So what I will do is I can go in and multiply both sides by r. Okay. Now squaring both sides is not going to help us here. Even though squaring both sides on the left-hand side will still give you r squared, but on the right-hand side, it's not going to achieve the r that we wanted. So I will not do that. So now I have r squared equals -8 r cosine of theta. R cosine of theta, I can totally now change that, right? And x squared, I can change that too. R squared is x squared plus y squared equals -8. This whole thing is x.
Then from here, I'm going to set it equal to 0. And the reason is anytime you see an x square and a y square, I know there's some sort of a circle going, okay, because they both have the same leading coefficient. I will move, okay, the positive ax on this side, add a blank spot, drop down the y square, set equals to 0. What I am doing is I'm completing the square to see how I can graph this without a calculator. All right, half of 8 is going to be 4, okay? 4 squares is going to be 16. What do you add to the left? You add to the right. So now I will, finishing up, completing the square. So I'm going to factor this out. This is x plus 4 squares, okay? Plus y squared equals 16. So this is a circle, and I will graph this circle using the rectangular format. I will not use polar. Again, I won't use polar until E and on, okay? So rectangular format said, hey, I can graph this out. The center is going to be the -4. So -1, -2, -3, -4. There's the -4. Let me make my x and y axis, okay? You can still use this and just change it into rectangular. You just have to go in and sometimes eyeball where the tick marks are, or just put in your own tick marks, okay? All right, so there's -4, that's my center, okay? Now, according to this, can you tell me what the radius is? Okay, so we knew the center. It's -4, 0. This is r squared, right, in the standard form of the circle. So radius is 4. So what that means is I'm going to go right 4, 1, 2, 3, 4, left 4, 1, 2, 3, 4, extend it a little bit more, okay? Up 4, this is the part where I said, like, it's kind of, I'm going to eyeball it, 1, 2, 3, and 4. So up 4 is that dot, down 4, okay? So here is 4 unit down, and then I'm just going to try my best to draw a nice circle. There you go. Okay, so that is my circle graphing using rectangular format. And this is the end of our video. Actually, you know what? Let me give you a joke, because I know last time you guys were bummed out that I didn't give you one. Why is it safe to tell a mummy your secret? Why is it safe in the spirits of holidays or Halloween, right? Why is it safe to tell a mummy your secret? It will keep it under wraps. Ha ha. All right, have a wonderful day.